Okay, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Welcome back. Okay, we're going to continue another example of dependent motion for kinematic of particle. Okay, this is typical quiz and exam question related to this kind of problem. So, if you look at this type of problem, I think quite clear there what you need to do. Okay. We study this diagram first. Look at this diagram. We have block A and B, and then poly. Okay. And then we have set the datum here. Okay, datum. We have datum. Okay, we have datum. Okay, we set going down is positive, right? All right. So what you need to do here? We have log A. Okay. And then we have block B, log A, log B. Log like by log through color D. Okay, color D. Via inextensible cable. As shown. Okay, so what is given here? We have both block A and color D move, and then you are given a constant acceleration. Keyword there, constant acceleration, 0.2 g. Okay, 2.2 g. So g is given here, which is 9.81 meter per second square, and the system start from rest. Start and initial, not moving. Okay, so what the question asks you to do? Okay, so you have to find the acceleration of block A. Okay, acceleration of block A. Block B, the corresponding acceleration of color D relative to block B. So relative velocity, relative acceleration is a very important concept. The corresponding acceleration of D relative to B, okay, and then C is you need to find the velocity of A after it has displaced 10 centimeter. Okay, and then what will be the corresponding time, and what will be the displacement of block A. Okay. So in this type of problem, you need to write a kinematic relation. Okay, kinematic relation, which is the length of the cable. Semua ni all together they are. Okay, that's why you can write as the following. So we cut, ambil scissor, cut two. So you can see here for A ada XA, D ni ada 2, okay, 2, and then XB 1. So you have XA plus 2XB plus XB equal to F. Okay. And then you do differentiate with respect to time. Okay. In this case, if you want to use both way also can, no problem. If you want to remain use X, okay, so it's going to be X dot. Acceleration is going to be X double dot dt. If you want to remain use X double dot, X double dot, X double dot. Okay, 2X dot, 2X double dot. Same thing for here, X dot B, X double dot B. Or you can write like what we did previously. Okay, which is you can write in terms of velocity, and then you can write in terms of acceleration. You write. So it can be both way. Okay, can be both way. All right. So given in the problem statement here, acceleration of A equal to 0.2 g, so 0.2 g. So you multiply 0.2 times 9.81. Okay, so 0.2 times 9.81. Okay, so 1.962, and the direction, don't forget unit, and then the direction. Okay, the direction. Okay, and you are also given here if acceleration of A is 0.2 g, so at D also is the same. Should be the same. The gravity acting towards it. Okay, onto it, which is 0.2 g as well. Okay, so here 0.2 g and AD also 0.2 g. Okay, so by using equation 3, which is this is equation 3. Okay, so you can substitute there 0.2 g, right? 0.2 g from here, 0.2 g plus 2 times 0.2 g as well, plus acceleration of b. Okay, so you can solve for acceleration of b from equation 3. Okay, so you get 0.2 minus, so you get 0.6. Okay, 0.6 g, 0.6 g, 5.886, 5.886, which is 5.89. Okay, so acceleration of A is 5.89, the direction is upward. And then we proceed with relative acceleration. Okay, so you need to find relative acceleration. Remember the definition of it: corresponding color D relative to B. So AD relative to B. So meaning acceleration of D minus acceleration of B. Okay. So we know acceleration of D. Okay. This is known. And that acceleration of B that we have obtained just now. Okay. In part B, part A. So 0.2 minus 0.6 g. So you get 0.8 g. Positive, huh? So you get 7.85 meter per second square. So 7.8 times 9.81, so you get 7.848. This one. So this is in terms of relative, relative block D to C. Okay. Okay, now it's part C. Okay, so part C. We have done part A, part B, part C. Now part C, need to find the velocity of A. Okay. Okay. Remember constant acceleration. So we use again this equation. Okay. Can use this equation. Can use this equation. Okay. To solve. So the for part C, simply you just use this equation and substitute the value. Okay. Substitute the value. All right. Comment here. Note that since acceleration of A equal to acceleration of D is constant, okay, in equation B, it implies that acceleration of B must also be constant. Okay. All right. Okay. Do you have any comment or question or your observation of this type of problem? Okay. Because when we do kinetic of particles, when it relate with this type of problem, you need to solve the kinematic first. The kinematic parts or the kinematic relationship must be obtained first before you can use uh, Newton's second law. Mm. So what I would suggest you is you need to, do a lot of exercise on how to write the kinematic relationship of this type of problem. Right? Look at the example and then how they obtain the kinematic relationship and how do the differentiation. The differentiation part is not difficult because no chain rule there. Is straightforward differentiation. Yeah. Okay. Okay. What I'm